Hello. So far we have understood the projection starting from the projection of points. So we have understood projection of points, and as if we have given this point one dimension, and this was we called this as a line, right? And then say we have given it one dimension, and to this, say on the same plane, when I am giving it the second dimension in this direction, in the second principal direction, so I get this as a surface or a plane, right? So we have made this as a two-dimensional element. Now the third principal direction remaining will be the axis which is perpendicular to the board. So as if I hold this plane and just pull it out of the plane, so that means here I will be giving it the third dimension, right? So the moment I give it the third dimension, so I get this required, so the object what I get, we are calling this as a solid. So you can see that a solid is a three-dimensional element, right? And now we are in this session will be trying to understand the projection of a solid. Now before moving into the projection of solids, let us first try to understand in a better way that what are solids in a way, or how we have categorized them. Now thing is that in actual practice or in real life, we may see that there are very much complicated shapes of the solids. Now basically these are all combination of various solids. So if we combine various regular solids with each other, we get the required shape. So that is why whatever we will be trying to project, they will be all kind of specific regular kind of solids. As we have seen even in case of projection of planes, we have considered all planes to be regular planes like hexagon, pentagon, right? But in actual practice, you may get a solid which is combination of say half of a hexagon and rest is a semicircle and like that. So these are called as composite planes. So in practice we may get situations or we will have situations where we will be actually projecting composite solids. But to understand, so if we say to classify as solids, so first basic classification or broad classification of solids, we classify them into polyhedron, right, and solids of revolution, or these are also called as generated solids. These are also called as generated solids. So let us try to understand. Poly means many, hedron means face. So polyhedra, if we say polyhedra are the solids which are having many faces, right? Faces, like if we see this as a solid, this pencil box. So this is a box which are having many faces. So it is having 1, 2, 3, 4, 5 and 6. So it is having a solid, or it is a solid having 6 faces, right? So polyhedron or polyhedra are the solids which are having different faces, many faces. Now this polyhedron are again classified into, you may say, again under 3 categories. One is prism or prisms, then pyramids, and then another category, they are called as regular polyhedra. Now we'll come to all these. So to understand what are prisms, now as I have just shown you that when we are giving the third dimension to a plane, we are achieving a solid. Now the way by which we are giving this third dimension, we will be generating or we will be achieving these solids. So for example, now say I consider the principal plane. So I am showing you the pictorial condition. So the parent plane, right, is a rectangle of side say L by B. So this is this face, right, and this is the say center of this solid. Fine. So now I am trying to get a solid out of this plane. So it is already having two dimensions. So if I take this as a reference, so it is having two directions in two dimensions in the principal direction. Now I want to give it a third dimension. So what I am doing is, just imagine the condition as if this is made of kind of a very soft kind of a rubber material, for instance. So what I do, say this is this plane and I glue it, one side I glue it to a solid surface, right, and then what we do, we pull this solid. So already it is having two dimensions. So this is one dimension, this is one dimension, two dimensions are there. The third principal direction in this case will be the vertical. So what I am giving is, I am giving the dimension in the third principal direction. So I am pulling this upper surface, the lower surface is glued, so as if it is getting stretched, right. So when it is getting stretched, we are stretching it in such a fashion, that all these four corners are getting lifted by same height. Fine. So all these four corners, they are stretched, they are getting stretched. So I'll be, so as if this will be, so now you will be able to understand the effect of the solid more vivid way. So what is happening, we have given it the third dimension in the third principal direction. Now this solid which we have achieved is called as a prism. So this is called as a prism. Now if you see a prism, now when we are lifting all these four corners by same height, that means the rectangle on the top will be same that as the rectangle at the bottom, right. So this two faces, they are called as the base of the solid, or they are the bases of a solid. So that means a prism will have two bases, right, and these faces, these four faces, as if this is the case. So this was the principal or the parent surface and I pulled it to same height. So it is same rectangle as these two as the bases, and these four faces, say, are simply called as the faces or the lateral faces. So these are called as the face or faces of the solid. Now when we have pulled it, so the center, so this center is also getting stretched. So center to center, if I join this line, so you will see that, so we have given the direction in the principal direction. So a dimension in the principal direction, that means perpendicular to the let us say the ground or the table from where we have lifted it. So this will be always perpendicular to base. Now as a matter of fact, you will see that when it is a solid, it is going to definitely have three axes. So one each in one of the directions of the dimensions, right. But when we are studying the solids, as far as our graphics are concerned, until and unless some extra thing is mentioned, extra characteristic is mentioned about the solid, we will be always considering the axis which is perpendicular to the base or the lateral axis of the solid, right. So when it is said that a solid is resting on HP and its axis is inclined at say 45 degrees to HP or VP, whatever, that means we are talking about the lateral axis, until and unless something specially is mentioned about that. So this is called as the axis, and we will be naming this as with reference to the shape of the base. So we have achieved it with the help of a rectangle, so we will call this as a rectangular prism. Now if I take a different plane, for instance, say instead of a rectangle I take say a pentagon, for example. So I take a pentagonal plane, right, and I now lift it the way just now I did it. So we will be lifting in such a fashion that all these corners, they are lifted by same height. So I will be getting, in that case, this as the solid, right. So I will be getting this as the solid. So here, just for giving you the effect of that solid, so what I do it, I show it in this fashion. So these will be hidden behind the solid. So this hidden concept will come into the projection when we are studying the projection of the solid. So you will see that we are getting this solid in this fashion, right. So it will be having these, this is one face, this is one face, so it will be having 4 faces, and I will be calling this prism as a pentagonal prism. So this prism is having these 2 bases, and it will be having these 4 faces. And another thing you will understand with this, that for any prism the faces are always rectangular. The faces will be always are rectangular, and these edges, what we are calling the edges of the base or the pentagon, we will be calling them as base edges, and these edges, they are called as the face edges. So this is what the solids which are called as prisms, right. So as if for the classification, so again if I show here, there is a, I take a hexagon and I give it a, right. So we get this as a hexagonal. So we get this solid as a hexagonal prism. And this being the axis of the prism, right. So this will be called as hexagonal prism. Now let us talk about the solids pyramids. Now again, these are very simple to understand. All of you must have seen tents, right. So how are they? They are, it is a kind of a shape where it is tapered towards one point, right, and that point is called as an apex. Now let us just try to see what is. So again, let's take a rectangle or a square, with the help of which we will try to so now again I take the parent plane to be as a square. So this is one dimension, this is the other dimension. So there are 2 dimensions now. Now my job is to, or my idea is to give it a 3rd dimension, right. Now we will change the idea of giving the 3rd dimension. In the last case, what we did, we picked up all the 4 corners and lifted them, right, as if we have stretched them. So we got a prism. Now here, instead of lifting all the 4 corners or pulling all the 4 corners, we will pull only one corner, and that will be the center point of this plane, right? So now what I do is I just pick or hold the center point of this plane, right, and I stretch it. Fine. So I'll be stretching it to give it some height. So let us say till this. Now we are doing it in such a way as if all these, so think of a cloth. When you pick up the cloth, when you pull the center, you will see that a tent is going to form, right? So same way, but we are regulating this pull in such a fashion that only these corner edges are getting stretched with it. Right? So all these corners are coming and meeting at this point. Fine. So to see its effect, so what I'll do is I'll show these lines as these broken lines which are hidden, right? So again this concept we will be understanding here. Now we show the hidden edges. So these are the hidden edges, right? So we see these solids. So these are the edges which are visible and these are the edges which are hidden, wherein I have not shown it here. So if I make, so those which are hidden, the moment I draw these hidden edges, you will see that you can make out which portion of the solid is visible or exposed to you and which is behind you. Immediately you can see the effect, right? So isn't it? So these things will be applied when we are. So this solid what we have achieved is called as a pyramid. So this solid is called as a pyramid. Now we have taken this parent plane as a square, so we will call this as a square pyramid. If I take a pentagon, right, and I pull the center, so in this case I'll get a pentagonal pyramid. So maybe in this fashion, right? So then I will be calling this as a pentagonal pyramid. So you will see that pyramids will have only one base. So this is the base of the pyramid. So one end of that, so this is the lateral axis again. So this axis, the axis which is perpendicular to the base is the lateral axis. So one end of the axis is base and the other end of the axis where all these base corners are coming and meeting, that means these face edges are meeting, this is called as the apex of the solid, right? And these are called as the faces, right? And you will see that in case of prism, all the faces, all these faces of a prism, they came out to be rectangular, but in case of pyramids, all these faces will be isosceles triangles, right? Because these two edges will be. Now in case of a pyramid, the faces are inclined to the base. You will see that because all these faces will be coming and meeting the apex. So these faces, they are inclined to the base. So that is why these are also called as the slant face, right? Hence these edges, the face edges, they are also called as the slant edges, the face edges or slant edge, right? And these are the base edges, this is the apex. So as far as nomenclature is concerned, then so that is how these solids are expressed. So these are pyramids, prisms. Prisms will have two bases, right, identical bases and rectangular faces. So name of the prism will depend on the shape of the base. Similarly, in case of pyramids, pyramids are the solids which are having only one base and the other end is an apex. So all the base corners are joined with the apex with the help of slant edges or face edges. All the faces of a pyramid are isosceles triangles and they are inclined to the base, and that is why they are called as the slant faces, right? So these are these two are then the pyramids and the prisms. So in this category, so let us again, as we are classifying them, so I'll just I'll here also I'll take up a pentagonal pyramid in this fashion. So this is the apex, right? So this is the base, this is the apex, and these are the slant faces. These are the slant edges. These are also called as the slant heights, and the axis which is perpendicular to the base. Now this is how we represent an axis line. So how we show an axis line? We represent axis line as one dashed lines. So like this we represent a axis line. Now let us see what are regular polyhedra. So a regular polyhedron is it means the faces are regular. That means all these faces will be identical. Now this regular polyhedra can be categorized into kind of a pyramidal and prismatic, right? So if we see example of prismatic, let us say if we take a square, so we take the parent plane from which we are generating the solid, or we are achieving the solid. Let us say it is a square. So that means all these edges are equal. So if this is L, this is L, right? So we are considering a square, and now we are giving it the third dimension like a prism, but we are lifting it in such a fashion now such that even the length of the height, or the height, is also L, right? So what we did, so third dimension also what we have given, we have so controlled the third dimension that this length is also, right? So here what I get, then all the faces to be as square. So I am getting all these faces to be as square, and we know we name this solid as cube. So cube is a solid which is having all the faces as square. So all the faces are identical. So as such, now in case of a cube, we cannot specifically say which one is the base, right? Because all faces are identical. So the face on which we are resting it, or whichever face we are considering that to be as the reference, we can call that as the base in this case. So this is called as a cube. Cube is also called as a hexahedron, right? So this is what will be one regular. So this is a regular polyhedron, right? So similarly, what is the solid which is like a pyramid? Then in this case, if I consider an equilateral triangle, right? So I consider an equilateral triangle. So this is an equilateral triangle. So L, 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 and now I am going to give it a shape of solid like a pyramid. So that means I'll pick up its midpoint and I'll stretch it. So this is the say axis. Now I'll be stretching it such that the length of the slant height, so this slant height what we are getting, this length of the slant height, the length of this slant height, this also comes out to be L, right. So if you see these faces now, these faces will be of L by L by L. So that means all these faces, they are equilateral triangles. All these faces in this case are called will come out to be equilateral triangles, right. So how many faces it is having? 1 at the bottom, 2, 3 and 4. So it is having 4 identical faces, hence we are calling this as a tetrahedron. So we are calling this solid as tetrahedron. So what is tetrahedron? Tetrahedron is a solid having 4 identical faces, and all these faces are equilateral triangles. So these two solids, they come under the regular polyhedron. In this category there are other regular polyhedrons are there, polyhedra are there. They are, one is octahedron. So octahedron is a, so if I want to show it, so we get octahedron something like this. So you will see, so it will be having 4 plus 4, 8 faces which are equilateral triangles, right. So this is octahedron. Then there are dodecahedron, so which is having 12 identical faces, and those faces are of pentagon shape, or they are pentagonal faces. So but we will be limiting ourselves as far as our projections are concerned to, so these two, the tetrahedron and the cube. So let us see the second broader classification, which we are calling them as the generated solids. So I'll just demark right. So these are the solids. So now we will talk about solids of revolution or generated solids. Now here just imagine these are the solids which are having one continuous phase, you can say, like in case of like this bottle, right. So it is having lateral phase, but it is one continuous phase, so there are no face edges in this, right. So it is cylindrical. So cylinders like, and cone, if you see again, cone is having one continuous lateral surface, right. So these solids are called as the solids of revolution or generated solids. Now why we are calling them as solids of revolution? Because if we see the fundamental how we are, so if I take a rectangle, okay, I consider this as the axis, right. Just you have to imagine this, right, and I just fast I roll it, right. So this rectangle is going to rotate about this line which I have considered. So it is going to rotate this way. So in the process this line will be generating a surface, and this surface is the lateral surface of the solid, which is one continuous surface, and this line about which we have rotated it, it will be perpendicular to the base. So this is the lateral axis of the solid, right? So these solids are called as cylinders, right? And similarly, now if I turn a right angled triangle, so I take this right angled triangle, again this line being the axis, and I rotate it, right? So this is going to get rotated this way, and I get this solid as a cone. So cone will have one circular base, right, and the other end is the apex, right, and the lines joining, so shortest line joining the two bases, they are called as the generators. So it will be having infinite generators. So in case of cone, again it will be having infinite generators. So for the projection of such solids, the solids of revolution, we have to consider the generators, and with the help of those generators then we project the solid. So cylinders and cones, they come under the category of solids of revolution, and there is a third category which are called as the spheres. So then what are spheres? Now that also is very simple to understand. So again, if I take up a semicircle and similarly I rotate it, so I'll get a ball, right? So these are called as the spheres, right? So these three solids, the cylinder, cone and sphere, they are the solids of revolutions. So that is how we categorize those solids into these various classification types, and now we'll try to see and understand how we go for the projection of the solids. So let's move on with understanding the projection. So again we can simplify the conditions, as we have seen in earlier cases also for projection of planes and lines, that we simplify the final condition. So we cannot put in all the conditions together to get the final projection or final image. So we step by step go. So let us understand that. So in that case, see, even while discussion I have mentioned that we are considering only the lateral axis of the solid. Lateral axis means the axis which is perpendicular to the base. So wherever I am referring axis in discussion, it is the lateral axis. So the first condition we can say, the axis perpendicular to, so axis is perpendicular to HP or VP. This is simplest condition. So two things we can understand. So axis parallel to axis perpendicular to HP or perpendicular to VP. That means, so if this is the base, for me this is a rectangular prism. So when we say axis, I consider, so these two are the bases in this entire solid. Only these two are the faces which are same. No, these are also same, but I take this as the parent one. So I consider this as the base. So when the base axis we are considering, when that is perpendicular to one of the planes, so obviously the axis will be parallel to the other. If the axis is perpendicular to HP, then it is parallel to VP. If the axis is perpendicular to VP, then it is parallel to HP. So this is one of the simplest conditions. So in this case, then, so pictorially if you want to see, so if say so this is HP and this is VP. So let us say there is a solid let us take this condition where axis is perpendicular to HP. So for example, then if I say, so there is this solid, again I take a, so there is this solid which is resting on HP on one of its bases, right? So let us see it this way. So this is this solid which is resting, or it is having its axis. So I'll show the axis this way. So from the center, so this is the axis of the solid, and this axis is perpendicular to the base. So now for the front view, so when you are looking at it from the front, you will be able to see the axis height, right, and the extreme faces. So for this image, if you want to see, so I have kept it in a simplest way such that this base edge is perpendicular to the reference line. So I'll be getting these corners projected in this fashion, these two corners in this fashion, these two corners in this fashion, this corner. So I'll get the front view of this solid. So I'll get the front view, in this case the front view of the solid as this, right? So I get the front view of the solid as this. So it will be a rectangle in this case, where I will be able to see the height of the solid, right? And when you are looking at it from the top, so you will be able to see only the base. So top view will, when we project the top view here, so you will get the top view to be as the true shape of the base, right? So this is the case where the axis is perpendicular to HP. So when the axis is perpendicular to HP, in the front view you are able to see the solid as a rectangle, and from the top view we are able to see the true shape of the base. So whenever we are trying to give inclination, so we may say this will be the initialization of the problem. So when we initiate the problem, so with reference to whichever principal plane the information is given, so we will be first placing it in this simplest fashion, so that we are able to see the true shape of the base in one view and the axis length in the other view. That is how we will always begin the problem, right? So this is when we are saying that the axis is perpendicular to HP. So for the example as I have taken, in that case I'll be able to see the true shape of the base, on the HP, and we were able to see the front view of the solid as this. Let us say the solid was resting on HP. So this is the axis of the solid. So we were getting the front view of the solid as this, and the top view as the true shape of the base when the axis is perpendicular to HP, this condition. Now when the axis is perpendicular to VP, let us again try to understand this with a pictorial representation. So this is the HP and VP, let us say. So this is the reference line XY, right? So this is the reference line XY. Now what we are saying, that the axis is perpendicular to VP. So for example, then in our case, when we keep this axis perpendicular to VP, so now in the front view we are able to see the true shape of the base in whichever orientation I place, and in the top view if I see, I will be able to see the height, or the top view projection. If I see, the top view will come out to be as a rectangle. So now if we place it perpendicular to, what did I say, perpendicular to VP. So when we take the solid as, say, so again I take a kind of square prism or a pyramid. So when I place it this way, So now you will see, so what we did, so axis, how is the axis here? The axis is this, and the axis is perpendicular to VP in this case. So when I project, you will see that the axis is perpendicular to VP. So when we are looking at it from the front, so in that case I will be able to see only the base of the solid. So when I am placing it, when I am making it perpendicular, axis is perpendicular to VP, that means the base is parallel to VP, right? So I will be able to see, so if we project it, so when we project it this way, so we get the front view as the front view of the solid as this, and when we look at it from the top, so when we project it, so we get the top view of the solid, as this, right? So this will come out to be the top view, which is a rectangle. So when we see, in this case the condition will be reversed. So when the axis is perpendicular, now here I have placed the axis on the horizontal plane, here let us say, so it will be above the HP, that is why I have considered, so let us say the base is not on VP, but it is, axis is perpendicular to both the condition we are showing, like, so this will come out to be as the front view, in this case the true shape of the base, and here as the true shape of the. Now you may even think of what will be the projection of a pyramid then. So if I take for the first condition, I say that there is a square pyramid resting on base on HP. So say the solid is in this fashion, right? So this is a pyramid which is resting on base on HP, right? Now here things will change a bit. This is the condition I am talking about when pyramid, this is a pyramid, base on HP, that is axis is perpendicular to HP. This condition we are trying to see how we will interpret the pyramids whenever we are drawing pyramids, because this is very important. So now when we look at the solid from the front, if I see, so when we are projecting it, so when we are projecting for the front view, so this will be on the base, so I will be able to see the base on the HP. So projector, the axis is this. So when axis is perpendicular to HP, that means we are able to see the true length of the axis, and let us say this is the axis of the solid, right? So the front view of this pyramid will come out to be as this, isn't it? The front view of the pyramid will come out to be as this. Fine. So simultaneously let us try to understand the orthographic. So this is the axis of the solid, and when we look at it from the top, so when we look at it from the top, of course we will be able to see the top view image as the true shape of the base, right? So we will be able to see the top view as the true shape of the base, which will be, if it is a square pyramid, so we will be able to see a square. Let us say the face edges are perpendicular to the VP or XY line. So in that case I will be able to see the top view of the base to be a square, right? Now how you will identify? So a pyramid with a prism. So this is the height we have seen. We are able to see the front view image as an isosceles triangle, right? But if you compare these two, here this is a square prism I am showing, and here I am showing a square pyramid. What will be the difference in the top view? See, when we are looking at it from the top, so whatever the slant edges are, they are also visible, right? So that means when we join these diagonals of this pyramid, see how the effect is going to change. And this is the apex. Please have a look at it. You will see that, of course, this is a pyramid, right? Imagine this apex is towards you, you are going to feel the solid, right? So that is how that makes the difference when we are drawing. So we will always make sure when we are drawing the projections of a pyramid, wherever we are showing the true shape, we need to draw the slant faces also, and we will never draw the diagonals until and unless as prominent edges, right? If it is required in case of a prism, whatever line you are using might be a construction line, but we will never make it prominent, otherwise the effect is going to change. So from the imaging views only you can see how it gives the effect, right? I hope you are feeling the solid. Fine. So this is the first condition we have talked about, where axis is perpendicular to HP or VP or one of the planes. And remember, this will be always the first or the initial step when we are solving a problem. So let us move on to the next step. So again, if you see, let us see the second case. For second case, say when axis is parallel to both the reference planes. So in that case, so if this is HP and VP, right? So we'll move on with this. So now say then the solid is maybe placed in the quadrant in this fashion, right? So in none of the views in the sense, the front view and the top view, we will be able to see the true shape. Rather, we will be able to see the true shape of the base in the side view. But in the front view, we will be able to see the true axis length, and the front view and the top view will come out to be the rectangle. So in this fashion, so I will be able to see the front view and top view as the rectangles, and in the side view when we see, so for the side view when we rotate and project it, so in the side view, left hand side view I have taken, so in the side view I will be able to see the true shape of the base, right? So this is the second condition. Now let us see what is the third condition then. So let's see the third case. Third case is when axis is parallel to one plane. One plane means, I mean by HP or VP, and inclined to other. So that means it is axis having one inclination and being parallel to. So in this case, what I can say, when it is parallel to VP and inclined to HP, this can be one case, and second, parallel to HP and inclined to VP, right? So again we will apply the logical reasoning for if I want to have one axis parallel to one plane, then what I can do, I can keep the base parallel to one of the planes. So if I make base parallel, that means parallel to HP, then the axis will become parallel to VP. So now I can give, so making it parallel to HP, parallel to VP, I can give it the first inclination. So that is why I have said always the first step for solving the problems of for the projection of solids, the first step will be always to see the true shape of the base in one view. So seeing the true shape of the base in one view ensures that the axis has become perpendicular to that plane, and that means it has become parallel to the other one, so that I can show the axis inclination, or as well as I can draw the axis inclination. So I can give it the first inclination. So this is the first inclination, and finally the fourth condition will be the oblique condition, that is, I can say axis inclined to both HP and VP. So for example, if we just want to understand, I'll again give you a pictorial understanding for this. So let us say there is a solid which is resting on, so in this case, so what will happen is, so this is the solid, so as if the other so I will just darken this for you. So this is one base, this is the other base, now say these are hidden in a way, right? So if you see this solid, right, so this is the base at the other side, so the axis is this, you can see, so this is the axis which is perpendicular to the base, as if you will see that this, if I extend it, this axis is inclined to HP by some angle theta, right? So when you are looking at it from the top, I will be able to see again the projected shape of the base here, right, and we will get the front view. So if it is resting, so as if we get the front view as so we will be able to see the front view as a rectangle, right? Sorry, this will be come out to be parallel to this one, so something like this you will be able to see. So this is the front view as if you will be able to see, right? And as well in the top view also you will be able to see a projection of this solid in this fashion, right? So this will be the condition of the axis when it is, I have taken this for understanding this as axis inclined to HP and it is parallel to VP. So that means if I want to go for the projection of this solid, so first I will make it stand on HP so that I am able to see the true shape of the base, and then in the front view I am able to see the front view as this and the axis as this, right. So let us say the axis is inclined to HP, so as if I am making it stand on HP, and then I am making it inclined to VP, right. So when I am inclining it to VP, keeping one corner, let us say one edge is on HP, so that means simply this solid will be tilted this way. So the front view is getting tilted in this fashion, and then we project it for the corresponding view. So we will get the corresponding top view. So this is the condition where axis is parallel to one plane and inclined to the other. So same can be, it is parallel to HP and inclined to VP, and final condition will be where the axis is inclined to both the reference planes, the HP or VP. So that means it will get tilted. So let me show you. So if this is the first inclination and then this is the second inclination, so this will be the oblique condition of the solid. So that's all in this session. And this session we have understood what are various solids, and then one by one what are the various conditions of placing the solid in the quadrant system. So that's all for this session.